Alright, for my next problem here, we're solving more equations with variables on both sides. As a reminder, the steps to do so are to simplify both sides by distributing clearing fractions and adding like terms. Then you move all the variables to one side of the equals, and then you move all the constants to the other side of the equals, and you divide to get the variable alone. First example today looks like this. So I changed my sign to plus the opposite. If you would like, you get rid of the smallest x by putting a negative x on both sides. So we're really saying what's 3 minus 1, which is 2x, plus 5 equals negative 13. I will move the 5 putting a negative 5 on both sides, and I get 2x is equal to negative 18. Divide by 2 on both sides, and I end up with the answer of, lost my negative right there, negative plus negative is a negative. Negative divided by a positive is a negative 9. On the next problem here, we are going to draw the line on the equal sign. I'm going to put plus the opposite. I've got like terms, so I've got 8x plus negative 3 equals 15 plus 5x. We're going to move the smallest variable to the other side, so I'm going to move the 5x over. That gives me 3x plus negative 3 equals 15. Then I would add 3 to both sides, and I get 3x is equal to 18. Divide by 3. X is 6. Question number 3. When we're solving this problem, I'd probably pick the 2c to move, so I'm going to move the 2c by putting a negative 2c on both sides. I still left with negative 10 equals 9 minus 2, which is 7c plus 4. Get rid of positive 4 by putting negative 4 on both sides. You get negative 14 equals 7c. And I'll divide by 7, which gives you negative 2 as your answer. On number 4, we're going to go ahead and solve this question. The only way I want to do this is move my x to the left-hand side. That way I have x's on the left-hand side and numbers on the right. I will move my positive 4x by putting a negative 4x on both sides. That gives me 2x equals, those go away, 20. Divide by 2 on both sides, and I get x is 10. The next problem, I just keep seeing the same things over and over and over. You should be at this point able to pause these and come up with the answer on your own. We're going to move the 2y to the other side by subtracting 2y. That gives me y plus 5 equals, those go away, 2. And I'll put a negative 5 on both sides. 2 minus 5 gives you a negative 3. Last problem of the normal ordinary type. I've got like terms on the left-hand side, which gives you 7x plus 4. On the right-hand side, I also have like terms, which gives you an answer of 32. From here, I'm going to get rid of the positive 4 by putting a negative 4 on both sides. I'm going to subtract it, which gives me 28. I'm going to divide by 7, which would give me an answer of 4. There are a couple scenarios that can also happen when you have variables on both sides, and those would be where you would get no solution answer or all real solution answer. So let's go ahead and look at how those take place. On this particular problem, I could combine my like terms and get 7x equals 7x plus 2. The reason why this is going to end up being no solution, and I'll go ahead and mark that, is I can logically talk this through. This person right here on the left-hand side makes $7 an hour. This person on the right had $2 in their pocket and makes $7 an hour at the same place they work. However, this person will always be ahead because they started with $2 more. So there's no way that these will ever be equal. How do you see that algebraically? Well, if you move your x's to one side of the equation, you end up getting 0 equals 2. This is an untrue statement, therefore it is always no solution. This is the symbol we use for no solution. You can also write the words no solution. On my next problem here, we're going to go ahead and combine all the like terms we can. So I got 5y and y, which is 6y, plus negative 3, equals, I've got 2y and 4y, which is 6y, and negative 7 and a positive 4 gives me a negative 3. Now, I really have the exact same thing on both sides, so I know the answer right now is all reals. How do you see this algebraically? Well, you can move your 6y to the left-hand side, which would give you a negative 3 equals a negative 3. This is always true, therefore the answer is all reals. It means everything works. This is the last problem for this video. So I'm going to change my signs to plus the opposite, plus the opposite, plus the opposite. So I end up getting 10 plus negative 9a equals 4 and 6 are like, so that gives me 10. Negative 2 and negative 6 is like, so that gives me negative 8a. This is also all reals because I have the exact same thing on both sides. Now, if you wanted to see it algebraically, you would add 8a to both sides, and that gives me the answer 10 equals 10, which is a true statement.